Dear and beloved students, welcome to our class. Chapter 4 Pressure. Before we discuss and learn about the pressure, I would like to say a very small story. An ass once carried through the streets of a city with a very famous wooden image. An ass was carrying a famous wooden image which was to be placed in one of its temples. As the ass passed along, the crowd made lowly prostration before the image. They were praying. They were putting their hands closed and bowing their heads down. The ass was thinking that the crowd was bowing because of a token of respect for ass himself. So, it was so proud. It was very arrogant and refused to move, and it was standing on the road. People were praying. The driver, seeing this whole drama, he took his whip lustily and he showed his shoulders all the energy on the ass. So, the over perverse dull-head ass thought that it is wrong. Okay? What exactly does it mean? The ass thought that people were lowly and with a lot of respect, with folded hands, praying him, but they were doing for the famous wooden image to be placed in the temples. So, what is the moral of the story? They are not wise who give to themselves the credit due to others. They are not wise who give to themselves the credit due to others. Okay, good. Now, let us discuss the pressure class. A small introduction, then importance of pressure on crop plants, very interesting. Basic pressure laws and or pressure variations or distributions. These are the things that we are going to discuss in a very elaborate and more easily understandable way. Dear students, the earth and its atmosphere. Okay, we have studied in several angles so far. The Earth's atmosphere weighs about 60,000 billion tons. The weight of the atmosphere on the Earth is 60 billion tons. It constantly presses upon our human bodies, the crop plant, the trees outside this classroom and the playground where you are going to play, all these things. At sea level, it exerts a pressure of about, it means the atmosphere. The atmosphere exerts a pressure of about 1 kilogram per square centimeter. 1 kilogram per square centimeter. See, that much is the pressure exerted by the atmosphere. As human beings, animals, etc., we got used to it, and the same is seldom felt. The force of gravity attracts molecules of air towards the central mass of the earth, but collisions between these molecules prevent the atmosphere from falling to the earth. The atmosphere won't fall on the earth because the collisions take place. That is the reason. As the air molecules are under gravitational pull of the earth, more molecules are held near the earth than at the higher altitude. This is what we discussed in the chapter 1. From this, it follows that the higher the altitude, the lesser the density of the atmosphere, hence lesser would be the pressure. As the height increases, pressure decreases. The concentration of oxygen in air is so low at higher altitudes, for example 7,000 meters or 7 kilometers, that the amount of oxygen required by crop plants for respiration is not enough to perform any physiological activity. Due to this reason or problem, the crop plants and vegetation become sparser and sparser as the altitude increases. As the height increases from the surface of the earth, the crop plants and vegetation become sparser and sparser, thinner and thinner. This is a small introduction. Now, let us go straight into the importance of pressure on crop plants. The effects of changes in atmospheric pressure on crop plants are normally studied in controlled environmental conditions because the temperature and other environmental elements also change markedly with changing altitude. The lower pressures experienced as altitude increases have important consequences for high altitude plant life. Plants growing on the hills, plant growing on the mountains. Okay, lower pressures are experienced by these plants at higher altitudes or higher elevations, and where there was atmospheric pressure low atmospheric pressure, the solubilities of carbon dioxide and oxygen in water are reduced. This has important consequences for respiration, which relies on the transport of these gases in solution. So it can be stated that as the height increases, the pressures are decreasing. At the lower pressures, the solubilities of carbon dioxide and oxygen in water are reduced. So, this has important consequences for respiration. Okay. Now, the plants show stunted growth at higher altitudes as concentrations of oxygen and carbon dioxide reaches low. The plants are stunted in growth at higher altitudes because the concentrations of oxygen and carbon dioxide reaches low. At higher altitudes, increased ultraviolet rays makes environment less favorable for plant growth. The plants with strong root system and tough stems can live under increased wind speeds at low pressures in high altitude areas. However, the response of plants to changes in atmospheric pressures has not received the same attention as that of solar radiation, temperature, etc. Okay, so the importance of pressure on crop plants can be summed up like this. As the height increases, the pressure decreases. At higher altitudes, the crops or plants grow with stunted appearance. Stunted growth is seen in the crop plants because the concentrations of oxygen and carbon dioxide reaches low. As the higher altitudes increased, ultraviolet rays makes environment less favorable for any crops to be grown. Therefore, the plants with a strong root system, tough stems, can live under increased wind speeds at low pressures in high altitudes, because as the pressure decreases and altitude increases, the wind speeds increase. Now, we just try to define one term, isobar. In the last chapter, before pressure, we discussed about the temperature. Isotherms, the imaginary lines drawn connecting the points of equal temperature, are known as isotherms. Now, isobars are defined as the imaginary lines drawn connecting the points of equal pressure. So far we have tried to understand how the atmosphere weighs, what is the importance of pressure on croplands, and what is isobar. Now, let us discuss some basic pressure laws. Simple. 2 laws and a small pressure gradient. Very interesting. Very interesting. You know the Dalton's law of partial pressures. You also know hydrostatic equation. Of course, pressure gradient also you may have studied. Just for this is a small recapitulation or just reviving your own knowledge on the basic pressure laws. Number 1, Dalton's law of partial pressures. The law of partial pressures states that the total pressure of a mixture of 2 or more gases or vapor is equal to the sum of the pressures that each component would exert if it were present alone and occupy the same volume as the whole mixture. Just a small explanation. Dalton's law of partial pressures states that total pressure of a mixture of 2 or more gases or water vapor is equal to the sum of the pressures that each component would exert if it were present alone. Of course, they occupy the same volume as the whole mixture. Now, a small explanation or definition of hydrostatic equation. In a simple way, I would like to enlighten you. The rate of decrease of atmospheric pressure with height is equal to the rate of decrease of atmospheric pressure. At what rate the atmospheric pressure decrease with height is equal to the product of density of air and acceleration due to gravity. The rate of decrease of atmospheric pressure with height is equal to the product of density of air and acceleration due to gravity. So this is a hydrostatic equation. And a small term, pressure gradient, small, very interesting one. Pressure gradient, it is defined as the decrease of pressure between 2 points along a line particular to the isobars. Isobars are the imaginary lines drawn connecting the points of equal pressure. Okay. Now, what is the pressure gradient? The decrease of pressure between 2 points along a line perpendicular to the isobars. Okay, is explained in pressure gradient in the pressure gradient term. What is it? The decrease of pressure between 2 points along a line perpendicular to the isobars divided by the distance between the points. This is what is pressure gradient. Okay, the decrease of pressure between 2 points along a line perpendicular to the isobars divided by the distance between the points. The isobars, very interesting things. Please understand, very interesting things I am going to give you. The isobars drawn closely on a weather map represent a steep pressure gradient and high velocity winds. On the reverse side, the isobars drawn farther apart on a weather map indicate a weak pressure gradient and low velocity winds. So, the pressure gradients are one of the primary causes of airflow or wind with the direction of flow from high pressure to low pressure areas. Okay, this is what is pressure gradient. So basic pressure laws, Dalton's law of partial pressures, hydrostatic equation, pressure gradient. So far we tried to understand the earth and its atmosphere, its weight, etc. The importance of pressure on crop plants. Plants show stunted growth at higher altitudes. Higher altitudes receive ultraviolet radiation, which makes environment less favorable for plant growth. The plants with a strong root system and tough stems are recommended or grown in the high altitude areas. As far as importance of pressure on crop plants is concerned, then we discussed basic pressure laws, Dalton's law of partial pressures, hydrostatic equation, pressure gradient. Now, the last component of this class is pressure variations or distributions. It's very interesting. I explained to you in a very simple way. Okay. Now, there are 4 types of pressure variations or distributions. There are 4 types of pressure variations or distributions. Number 1, horizontal pressure variations. 2, vertical pressure variation. 3, diurnal pressure variation. 4, seasonal pressure variation. Now, what is the meaning of pressure variations or distribution? If you take the number 1, the horizontal pressure variation, temperature and pressure are inverse to each other in general. Temperature and pressure are inverse to each other. Along the equator, low pressure. The low pressure areas near the equator, we call them as the doldrums. Okay, along the equator, low pressure. Doldrums exist, and in polar latitudes, polar high exists, and these are the classical examples of horizontal pressure variation. That means the temperature and pressure are inverse to each other. Along the equator there is a low pressure, okay, and in polar latitudes, otherwise polar latitudes, there are polar highs, and these are classical examples of high pressure. So where there is a low pressure, okay, there is a high temperature. Where there is a low temperature, the pressures are high. This is what is we call it as horizontal pressure variation. Of course, the horizontal variations of the air pressure on the surface of the earth are indicated usually by isobars. I defined isobars while discussing with you a couple of minutes back. Isobars are imaginary line drawn connecting the points of equal pressure. Now, the horizontal variation of pressure depends on temperature, extent of water vapor, latitude, land-water relationship, etc., etc., etc. This is horizontal pressure variation. What exactly is the simple summary? The simple summary of horizontal pressure variation is temperature and pressure are inverse to each other. Near the equator, where temperatures are high, low pressure exists. Near the poles, where low temperatures are there, high pressure exists. This is horizontal pressure variation. Now, what is vertical pressure variation? The vertical pressure variation means the downward force on the atmosphere compresses it so that the greater part of the mass of the air is concentrated in the lower layers, and the atmosphere declines rapidly with increased altitude. What is the meaning of it? As the height increases, the pressure decreases in the first layers of the atmosphere: troposphere, stratosphere, mesosphere, all these areas. The changes in the atmospheric pressure with altitude, okay, is an important indicator of the wind speeds. As the height increases, pressure decreases, wind speeds increases. That's why in the importance of pressure on croplands, we tried to understand that plants with a strong root system and tough stems only can survive because of this reason. Vertical pressure variation, pressure decreases, wind speeds increases. Therefore, the plants with a strong root system and tough stems can live under increased wind speeds at low pressures in high altitude areas. Good. Now let's go to diurnal pressure variation. Apart from the variation of pressure due to movement of atmosphere, the pressure varies diurnally. There is a definite rhythm in the rise and fall of air pressure in a day. The meaning of diurnal is day and night, diurnal. Okay, so in a day, the pressure variation, okay, may be due to movement of atmosphere. Of course, the first foremost important thing is the insolational heating and radiational cooling are the main reasons for diurnal variation in the air pressure. That means in a daytime the temperature goes on increasing from 6 am to 2:30 or 3 in tropical areas. Generally from 2:30 to next morning 6 the temperature goes on decreasing. So as the temperature increases, pressure decreases. As the temperature decreases, the pressure increases. It is because insolational heating, that means air expands, and radiational cooling. Of course, when it is cooling, air contraction takes place. This is the reason for the diurnal pressure variation. Diurnal variation is more prominent near the equator than at the middle latitudes. Okay. This is what is a diurnal pressure variation. Horizontal pressure variation. The horizontal pressure variations are due to low pressure, high temperature near the equator, low temperature, high pressures at the poles. That is horizontal. Vertical, as the height increases, the pressure decreases. The diurnal pressure variations are due to insolational heating and radiational cooling are the main reasons for diurnal variation in the pressure. Now, the last one of pressure variations or distributions is seasonal or annual pressure variation. The seasonal variations are more pronounced, particularly over land masses where heating and cooling of air has a large effect as compared to oceanic areas or sea areas. The seasonal variations are more pronounced over the land as compared to sea or oceanic areas. Due to the effect caused by annual variation in the amount of insolation, distinct seasonal pressure variations occur. Why distinct seasonal pressure variations occur? It is due to the effect caused by annual variation in the amount of insolation, incoming solar radiation. So, the insolation, the receipt of solar radiation has a distinct influence on the pressure variations in seasons. These variations are larger in the tropical region than in the middle and polar regions, like diurnal pressure variation. Diurnal variation is more prominent near the equator than at the middle latitude. Same is the case with the seasonal or annual pressure variations. That means these variations, seasonal or annual pressure variations, are larger in the tropical region than in the middle and polar region. Usually, high pressures are recorded over the continents during the cold season, and over the ocean they are observed during the warm season. Usually high pressures are recorded over the continents during the cold season, and over the ocean they are observed during the warm season. This is usually, this is not specific, this is not a thumb rule. So with this we conclude our basics one of pressure, where we discuss the Earth's atmosphere weigh approximately 60,000 billion tons. Importance of pressure on croplands. Plants show stunted growth. Plants at higher altitudes, okay, cannot be grown because of ultraviolet radiation. Therefore, plants with high, okay, or strong root system and tough stems are recommended. Basic pressure laws, of course, Dalton's law of partial pressures, hydrostatic equation, pressure gradient we studied, pressure variations, horizontal, vertical, diurnal and seasonal. Thank you. We meet in the next class to discuss the second part of our pressure, basics 2. Thanking you very much.